Okay, so we're going to do some more factoring. We're looking at factoring some special polynomial forms. So we're going to be looking at perfect square trinomials and a sum or difference of two cubes. So we have some formulas here, but I'm just going to get started with the example. So example 9, it says to factor each expression. Let's look at 9a. It's x squared plus 6x plus 9. So again, going back to our factoring rules, the first step is to always look for a GCF. So when I look at these three terms, they do not have anything in common greater than 1. So there's no GCF. So then we go to step 2. Based on the number of terms, that's how I know how to factor. Well, this is a 3-term polynomial, so it's a trinomial. Coefficient of x squared is 1. So the way I would look to factor this is to just split this up, x and x. And then I'm looking for factors of the 9, the last term, that are going to add up to 6, the middle term. So everything here is positive. So it turns out that that would be a plus 3. So x plus 3, x plus 3. So again, it's 3 because 3 times 3 is 9, that last term. 3 plus 3 is 6, that middle term. So that's how this one factors. And because I have the same factor repeated, x plus 3 times another x plus 3, I can write this as x plus 3 squared. Okay, so this matches. This is a perfect square trinomial of the first form, the top, because this was my factorization of that form. So let's look at this a little bit more. So this represents a perfect square trinomial. So why is that? So a perfect square trinomial is going to factor to the same, to a repeated factor, so the same factor written twice. But how are you going to recognize that? Well, you're going to recognize that when the first term is a perfect square, so x squared has a square root, which is x, and the last term is a perfect square. Square root of 9 is 3. So let me write that here. So square root of x squared, perfect square, that's an x. Square root of that last term is a 3. So then when you take these and you multiply them, x times 3 or 3 times x is 3x. When you multiply them and double them times 2, what do we get? We get that middle number, 6x. So those are the characteristics that they have here, okay? First term is a perfect square, last term is a perfect square, and their square roots doubled is the middle term. So if you can recognize that, that helps with the factorization. So we know that it's going to be the square root is the first term in the factorization, the square root of the first term, and then the square root of that last term is the second term in the factorization, and we look at the sign of the middle because it was plus, it's a plus, okay? So that's a property that we can look at. Now, actually, I think that knowing that it's a perfect square trinomial helps when we're going backwards, when we want to expand the x plus 3 squared, for example. And that's when I think this formula is the most helpful. So going backwards, if I want to multiply the x plus 3 squared, so I would normally just do x plus 3 times an x plus 3, and then I would FOIL this out. So x times x is x squared, x times 3 is 3x, then 3 times x is another 3x, 3 times 3 is 9, and then when I combine the middle terms, those like terms, I would get x squared plus 6x plus 9. So this again is my original expression, x squared plus 6x plus 9. So I know I did that correct, but knowing that this was a perfect square trinomial, I could use the formula to multiply it out. So the x plus 3 is my u plus v squared. So let me write the formula. So it'd be u plus v squared equals u squared plus 2uv plus v squared. So in this case, u and v are x and 3. So using the formula, I could multiply the x plus 3 squared. Instead of FOILing, I can plug it all into the formula. So u squared becomes x squared. So you take the first term, square it. And then 2uv, then you take the two terms multiplied. So u and v are x and 3. So you multiply those, you get 3x, but times 2. So you double that. So that's the 6x. Well, actually, let me plug it in so you guys can see that. The u, v. And then you take the last term squared, which is a 3 squared. So again, knowing that formula could help you multiply this out. So again, it's the first term squared, x squared. Then you multiply the two terms and double them. So that's going to give you 6x, which is what that simplifies to. 2 times x times 3, 6x. And then you take the second term squared, which is 9. Okay. So these are just properties to recognize special types of polynomials to recognize. Well, this isn't the answer. This is actually just the check. And this is showing that this is the same as the original polynomial that we started off with. But actually our answer is up here, the factorization. So these are all perfect square trinomials. So let's look at the other one. Part B, we have an x squared, we have a 9. So again, normally we're just looking for factors of the 9, that constant that add up to the middle term, a minus 6. And it's a minus 6, so it's going to be a negative 3 and a negative 3. Again, it is the same factor twice, x plus 3 times another x plus 3. So it's minus. X minus 3 times an x minus 3, so x minus 3 squared. But again, this is a perfect square trinomial because the x squared is a perfect square, the 9 is a perfect square. You take those square roots and double them, we get 6, but it's a minus 6. So that just determines that the sign of those should be a minus. Okay, x minus 3, whereas the other one was a plus. So we have one more example. Let's look at that one. First term x squared, that is a perfect square. Square root of x squared is x. The last term 1 is a perfect square. Square root of 1 is still 1. When I multiply those and double them, I do get the middle term 2x squared. So that's how I know this is a perfect square trinomial. So it's a plus sign in front. So this would factor 2x plus 1 squared. So again, that's a trick to help you out if you recognize that. But you could always still look at what are factors of that last term, the 1, that add up to the middle term 2, and it would be a plus 1, plus 1. So you would get that same answer, that same factorization. But it doesn't hurt to have just other tools and properties to recognize. Okay, so moving on, we have some examples. Now we have two-term polynomials. Looking at D, E, and F, these are two terms. So we can factor two-term polynomials if they are both perfect squares and a subtraction between them, so a difference of two squares. But we can also factor if both terms, when we have two terms, if both terms are perfect cube numbers, and they could either be a sum or a difference of the two perfect cube numbers. And the way that you would do that is using the formulas down below. So I have the formulas over here for sum or difference of two cubes. So again, if you recognize two numbers in a binomial, so when you have two terms, if you recognize that they're both perfect cubes, we can factor, and I'm just going to use the formula. So part D, x to the third plus 8. They are both perfect cubes. Cube root of x to the third is x. So let me write that. Cube root of x to the third is x. And the cube root of 8 is 2. So these are both perfect cubes, and it is a sum. So I'm going to use that first formula. Okay, so one formula is for the sum of two perfect cubes. One is for the difference. So I'm going to use the formula for the sum. My u and v in this case are the x and the 2, because those are the cube roots of my values, okay? So I'm going to rewrite this formula, u to the third plus v to the third. It's u plus v, and then you square the first term, you subtract the product, and then you add the square of the last term. So again, my u is the x, my v is the 2, because 2 to the third is 8. So I'm looking at the cube roots of both of them. So to help me out, really, wherever you see a u, you plug in the x. U is x. And wherever you see a v in the formula, you plug in a 2. So that's how this works. So it really helps just to know the formula. So u plus v is going to become x plus 2, cube roots. U squared is the x squared minus u times v, so I multiply those two cube roots, plus v squared, so you take the cube root of the second term, squared. So let's clean this up, simplify x plus 2 times x squared minus 2x plus 2 squared is 4. So that would be my factorization for the x cubed plus 8 right there. Okay. So depending on whether or not your problem is an addition or a subtraction, you have the formula below to look at. Okay. So I'm going to skip to F. Let's look at that one. 125 minus x to the third. These are both perfect cube numbers. Okay, so the the cubed root of 125 is 5. The cubed root of x cubed is x. So I can use the 5 and the x to help me factor here. And this is a difference between the two, so I'm going to use my second formula. So it's u to the third minus v to the third. I'm just rewriting that formula down there. U minus v, u squared plus uv plus v squared. So what are u and v in this case? U and v are the cubed roots of the terms in the expression. So the cube root of 125 was 5. So 5 is my u. Okay. And the cube root of the x to the third was x. So x is the v. So I'm going to replace the u with a 5, so it's a 5, and the v with x in my formula. So again, helps to know the formula. I'm just doing some evaluating. So u, 5, minus vx, u squared, so it's that 5 squared, u times v, 5 times x, plus v squared, and that's my x squared. Okay, so order matters. So because the 125 was first, that's the u. It was minus the x to the third. So the cubed root of that is the v. So the cube root of 125 is the u. The cubed root of the second term is the v. So simplifying here, 5 squared is 25. 5 times x is 5x, and then x squared. So we want to rewrite these because normally we see the x squared term first. So we can do that. So times x squared plus 5x plus 25. So you would check to see that nothing else can be factored out, and it can't. So this is my factorization here. So keep these formulas handy, especially for the sum or difference of cubes, so that when you recognize an expression as a sum or difference of cubes, you can do that factorization. So we've gone over all of the methods and ways for factoring. So just to remind you, you do have a factoring map at the end of this section to help you. It goes over the steps for factoring, starting with factoring out a GCF if possible. Then we have the techniques for how to factor 2-term polynomials, your 3 terms, your trinomials, and then your 4 terms, your factor by grouping, and you have some examples. So factoring is an important strategy that we're going to use in this course. So keep this handy, and good job with your factoring.